Hello and welcome. So now we will be talking about the most critical pillar in this framework, which is the security pillar, pillar which is considered the first pillar to be done by various customers, and you would know why, right? So quickly, let's deep dive into the design principles, part of the security pillar, and the details around it. So, these are the design principles. But before we deep dive into it, one quick question. Have you heard about the shared responsibility model and what it is, right? So, the shared responsibility model around AWS is basically security of the cloud and security of what is in the cloud, the responsibility. So, anything that is at a physical layer or even at the hyper as a layer, that is security, and responsibility of the security of that is of AWS. They will ensure that the infrastructure is secured, the hypervisor that is being utilized to manage the VMs is secured. So anything above that, whose responsibility is that? So that is customer responsibility, or you as a user who is implementing it for your customer, for yourself, or for your team. So ensure the security of what is in the cloud while you do the implementation. We'll take few references in the same context while we discuss the security design principles. All right. So, what is the first design principle that we're going to talk about? That's implementing a strong identity foundation. So, basically, these are three things that I would like to break it down into. The very first being least privilege access. Uh, that means to ensure that you have the access that is required for you. But how do you do that? You do that by segregation of duties or separation of duties. That is, segregating things. This is a developer team, this is a security team, this is a DBA team, this is a finance team which needs access only to billing details. So this way you ensure that by segregating the duties of a particular team, they get only the required access for achieving the task they need to do. As I said, maybe a finance team does not need access to EC2s, Lambdas, RDS. They need access only to the billing functionality, cost explorer, and so on and so forth. So this way, you ensure that they are given least privilege access to that particular account. Furthermore, drilling down, this can be done based on tags, where we can restrict access to a particular user to a particular environment based on tags, saying that only the UAT and development environment needs to be made available or accessible to the developer team. Right, a testing team needs access only to UAT team. The prod environment should not be accessible to anyone. So ensure that the access given is least privilege access. All of that based on the segregation of duties. But the best way to manage this while you grow as an organization or as a team is to centralize and automate it. How do you do the centralization and automation? Is by an example could be utilizing your your organization AD, link it with your IAM user groups, or the way you have AWS groups, IAM groups that you have, right? And in as part of it, ensure that any new user coming in is added to a group, and if he or she is leaving the organization, the access is automatically revoked. So this way you are centralizing it and automating it. Another way is to create a identity AWS account, create all the users in that specific account, and then provide access from that account to other child accounts that you would have, right? Or member accounts as they call it today. So that's the way you have to approach centralizing it and automating your identity management, right? Setting up the right foundation for it. The next aspect is enabling traceability. When I say enabling traceability is on multiple fronts. One is to monitor and alert what is happening in your ecosystem. Ensure you're able to monitor it and set up the required alerts based on what you're monitoring. Know your KPIs basically. Next, after beyond that is auditing what is happening, auditing the actions and the changes that are happening in the account. And all of that at scale would be very difficult to handle, and that's where we would say we need to automate the entire process. So ensure that you have monitoring, you are able to trace, you have the required data. Beyond that, you audit changes and the actions and the changes, and on the entire process that we are speaking about has to be automated. Next is apply security at all layers, that is defense in depth approach, which means that all your layers that is there, as an example, is to have a secure way of setting up your VPC, ensuring that you have network security right from VPN to security group setup on it. The next one is at an application level, ensure you're practicing all best security practices and while coding. While deploying, ensure that your AMI is using the golden image or the hardened AMI that you have from your team, which has all the required security patches on the OS and at the programming language level. So maybe the engine that you're using, ensure that it is all patched and does not have any vulnerability. So this is an example and or an overview of the various layers that you need to ensure security is implemented. And finally is of course the security layer, the network layer using SSL, the policies which is least access into the AWS ecosystem, or even to your dev environment and so on and so forth. So these are very few examples, but see in your scope of work what is applicable and where you can ensure that you have defense in depth approach, right? Next is automating security best practices by templatizing it and by automating it, which means that if you want to create a new user, you don't have to set up a new policy every time and manually create it. It can be automated based on the user group or role, and then get it attached to a particular group and move ahead. So this way you are templatizing it and automating it to reduce human error. Now, the last three design principles that we would talk about would be basically self-explanatory ones. The first one being protect data in transit and at rest. This basically means to ensure that all your data that is being transferred or communicated is encrypted. So let's say an example is any data being pulled out from S3 should be only HTTPS. So you could add a policy into S3 saying that if there is no SSL cert or HTTPS request coming in, deny any pull or a put object out of it, a put object into it. So that's one way. On transit, at rest, how do you encrypt your EBS volumes, your S3 buckets, and so on and so forth. So there are a few examples. Next is to ensure keep people away from data, right? This way you ensure that there's least data being accessed by humans and reduces the blast radius. And of course, all said and done, you're all prepared for everything. Prepare for security events. It will happen, and make sure you are able to have a particular process so that in case of an eventuality you're able to tackle it gracefully. So what are the best practices and what are their enablers, right? Ensure your identity and access management foundation is strong while you're using IAM and STS to do that. Next is use detective controls such as CloudWatch, Config, and CloudTrail so that you have the right detective controls in place and you're able to monitor and alert on this case. The next one is infrastructure protection. ensure you're having the right VPC configuration, security groups, hardened AMIs, and so on and so forth, as a few enablers. There are many more trusted advisors that can be used to ensure to get the right advice in place. And finally is data protection, encryption, security groups, and certificate manager to have your SSL certs, right? And beyond that, if in case of any event, is incident response. So you use CloudWatch, CloudFormation, and EventBridge to track everything and ensure that you're able to respond to an incident efficiently, right? So, in summary, what I would like to call out is security is a day zero activity, right? And it will, or it should always be the first thing that you work out for the solution that you are working on, right? Be it coding, be it architecture, be it testing your ecosystem, anything, any scope of work, ensure security is the first and foremost thing that you discuss and work out and have a solution in place. That having said, it is an ongoing activity. It's a never-ending activity, and which will all you have to ensure that you keep up with the cyber threats that are there in the ecosystem and that are evolving. So you need to evolve as well and ensure it's an ongoing activity. I cannot stress much, more on this. Be aware of the shared responsibility model that we spoke about. Be sure that if you're a beginner, to understand what are your responsibilities while utilizing cloud, and to put that across. Ensure that you have a understanding of it. Uh, and to reduce any human error, automate and templatize it as much as possible, right? And all having said, prepare for the worst case scenario. So that's a quick wrap on what the security pillar is, what to take care while working on security aspect for your ecosystem. So hope you got some details out of it. The next pillar that we will be talking about is reliability pillar. See you then.